Hello, statistics student. This video is for chapter 6.2, using the normal distribution. So basically, we're going to use the online calculator to find probability of x that is really a value that is applicable in real life, like x could be height, could be test score that is normally distributed, like a lot of standardized test score is normally distributed. And then we want to find, what is the probability that if they are normally distributed, that the score is between like 75 to 82, like that. So it will not be using z-score to do it. We use directly the mean and standard deviation sigma. So if we would use a notation of n, open parenthesis, mu and sigma to denote something that is a continuous random variable, but it's normal with the mean and mu and standard deviation of sigma in this notation, and open parentheses, like that. So if you see this, that means you're referring to something that is normally distributed. And if a particular x values is normally distributed, then it can be modeled by a density curve like this. Okay, so the mean is in the middle, is symmetrical, and the standard deviation is sigma, right? The standard deviation is sigma. It should not be sigma square. I think there's a typo here. So, and then the one way to find this particular area is translate all of the x to z. You recognize that x minus mu over sigma is actually z, right? So you will be using the standard normal that we have in 6.1 to find the area. It turns out that this particular density curve that is more complicated actually also had a total area under 1. They're more spread out. This is just between 0 and 1 there. And they have negative and positive, -1, -2, like this. But this is a regular normal distribution where you would have mu, also 1, 2, 3, but this is plus sigma, plus 2 sigma, plus 3 sigma, minus 1 sigma, minus 2 sigma, and minus 3 sigma. So, but they could be positive number. So this is symmetrical on the y-axis, but this is not. It's just an x value. But it turns out that the area are the same. The total area of this curve is 1. This total area is also 1. It looks bigger here because of the scaling, but they're actually the same. And so to convert from x to z, you would say z is equal to x minus mu over sigma. We always use that. And then this bell curve has the same properties. Half of the data that is greater than mu is 0.5. Half of the data is less than 0.5. So the probability of having a x that is greater than the mean is 0.5. The probability is less than is 0.5. Only if it's normal though, right? Of course. And if you want to find the probability of x is between two number a and b, that is to find the area underneath this bell curve. Of course, to find it, we would actually use the online calculator from StatBook, online StatBook, online calculator. The only change is you, instead of using mean equal to 0 and standard deviation equal to 1, you would use mean the actual mean and the actual standard deviation. You use left to find left area. You use below to find right area, you use above to find in between, you use between, and outside, you use outside and recalculate. You can also use the inverse normal calculator to find x cutoff for percentile, for a given area, a given percentage, a bottom percent, top percentage is exactly the same. So the general guideline is if you are doing top percentage is above, right? And then you use inverse on the calculator, but use above. If you're using percentile or bottom percentage, K percentile or bottom percentage, then you use inverse calculator below. So without further ado, we'll just work on a example. So basically, it's the same thing. If you look at the calculator, we use the normal calculator, change this to the real one. And also we use the inverse calculator, change this mean and standard deviation. Everything exactly the same. When we do this kind of question, I want you to draw the picture. Okay. So sketch the area, and in order to sketch the area properly, because you really don't know what your x is sometimes, right? It's no longer 1, 2, 3. So a lot of time we calculate z to tell us how to label the x-axis, because otherwise you just really don't know. Okay, so the mean is 63, but where is 60? Uh, More than 65, but where is 65? Is it here or is it at the end? So you don't know unless you calculate z. So usually to draw the picture, we would actually need to see so that we know exactly which tick mark around where we would mark it. So for example, a standardized test is normally distributed with mean 63 and standard deviation 5. So you can write 63 here, and it's 5 each, right? But I don't need to write it. I can say it is 68, right? Plus 5. And then you will say, oh, it scored more than 65. 65 would be around here, right? These are more than 65. And to find probability would be get the 65 here and do it like this. Another method is actually calculate what is z equal to for 65. 65 minus 63 over 5 is 2 over 5 is 0.4. So it is 0. It's in the middle. 0.4 is really close to 0. So you know that, oh, I just mark it here. And so for the online calculator, and you can see that if we do it using Z or using the direct 65, you get the same answer. So let's try. We are finding probability, so we just use the online calculator. And then our area would be here, right? It is 63 standard deviation 5. And we want it to be about 65, right? And we recalculate. So it's 0.3446. So probability. So probability is 0.3446. So that there you are. Okay. Above, because this is above. Now we can also use the z-score to do 0.4. So see if it's the same. So if the z-score is 0, 1, and then would be above 0.4. Recalculate 0.3446. They're exactly the same. So the graph is different, but the area is the same. The second example, find the probability that the score is less than 85. So where is 85? I only know that this is a 63 in the middle. So you can add those numbers and subtract those numbers, but you can also find a z. Z is 85 minus 63 divided by 5, right? Minus the mean divided by sigma. Okay, 85 minus 63 and then divided by 5 is 4.4. Well, really far away, right? So usually we would do 1, 2, 3. 3 tick mark is already, at the end. So 4 would be here. Less than. Whoa, that would be all this. Do you think it is 100%? I have a feeling it is. So this is 85. It is 4 standard deviation away, and we want it to be less than 85, like that, right? So all of them. Theoretically, we would not have anything that is below, 4. But so let's change this to 63, 5, and it's below, right? So click below, but I don't want 1.96. I want 85. Recalculate is 1. So we say 100%. Probability, you can say 1. So find the 90th percentile score. So this is 63.5. So what is the score that is at 90th percentiles? So this is the cutoff, right? Is X value. Percentile is percent, right? So we can roughly say this is the percent, 90%. We know half of it is 50, so 90 must be on this side. So we want to know what x is. This is inverse normal. Do you agree? Because we are finding x. So our area is 0.9. It is below, right? And then we don't have 0,1, but 63,5. We calculate 69.408. 69.408. So x is less than 69.408 is 0.9. So that this score 69 is the 90th percentile. So if you score 69, you're at the 90th percentile. Another example is about height. Okay, it's a height of man are normally distributed with mean of 68.6 and deviations 2.8. Find probability. Find probability means find area that the man has a height greater than 72. So we do not need to use inverse. We would use the normal one. What was the 68.6? This is the mean. And the standard deviation was what? 2.8. And we want it to be what? Greater than 72. Above 72. So we would just do recalculate is 0.1123. 0.1123. So above. Now I can try to calculate z because I want to draw it, so I really don't know where to click it. So we can do 72 minus 68.6 over 2.8. What would that be? 72 minus 68.6 and then divided by 2.8. I have a z-score of 1.2, so you know that this is actually just one tick mark away, and then it is greater than 1.2 tick mark. So it just gives you a better idea on how to sketch it. Okay, but in terms of the area, the percentage is 0.1123. So I'm going to stop here and then do the rest of the example in the next video.